Hello again. So here we have a problem where we are studying the change of length due to elongation of a given copper cylinder and a brass cylinder. They are stacked to each other as shown in the figure. We are given the radii of the cylinders. Both have a radius of 0.25 centimeters. We exert a compressive force of magnitude 6,500 newtons. It's applied to the right end of the brass cylinder, and we want to find the amount by which the length of the stack decreases. We are given the values of the Young moduli for copper and for brass. So we can first recall the formula for the force that will give us this compression. F is equal to the Young modulus times delta L, which is the elongation, over L0, which is the initial length, times the A, which is the cross-sectional area of the object, which is here a circle, obviously, because we have a cylinder, so the cross-sectional area is the area of a circle. Now what we want is the amount by which the length decreases, so we want delta L. We rearrange this equation in terms to find an expression for delta L, and this will be F L0 over YA. Now we have two different materials, so it's better that we consider them separately because we have different Young moduli for each cylinder. And so we can just find the decrease in the length for each material, and finally the total decrease will be the sum of delta L for each cylinder. So we start with delta L of copper, and it will be FL0 over Y of copper times the area, and like we said, this is pi r squared. So this will be 6,500 times the initial length is 3 centimeters, which is 0.03 meters, over the Young modulus for copper is given, it's 1.1 times 10 power 11. You can see it right here, times pi times the radius, which is also given to be 0.25 centimeters, and this is squared, of course. If you calculate this, you get 9 times 10 power minus 5 meters. And with a similar calculation, you can find the change in the length of brass, and it will be 1.8 times 10 power minus 4 meters. Of course, the initial length is different, A is the same, and the Young modulus will be different. And finally, the total change in the length is going to be the sum of these two, and we will get 2.7 times 10 power minus 4 meters.